Hello friends, welcome back to my YouTube channel. So in last video we have seen a problem of continuous beam, and in today's video we'll see one problem of frame by using the moment distribution method. So this is the given frame. So first, as usual, we need to find out the fixed end moment. The first step is to find out the fixed end moment. So for span AB, I'll find out fixed end moment for AB is equal to 0 because there is no load at span AB, and also for BA is equal to MF BA is equal to 0. So MF AB as well as MF BA is equal to 0 because at this condition no loading takes place. So now for span BA, span BA, we have the formula minus WL square divided by 12, minus because it is anti-clockwise. So load is 20, our span is 3 square divided by 12. So by simplifying it will come out as minus 15 kilonewton meter. Similarly, we will calculate for CB. So formula is, this is clockwise, WL square divided by 12. So it will come out as, formula is same, only sign will change. It means the answer will come out as 15 kilonewton meter. Now we'll go for the span CD. Span CD and DC also fixed end moment is equal to 0 because here there is no loading takes place at this span. So this is the fixed end moment for this frame, given frame. So our next step is to find out the distribution factor. Our step 2 is to find out the distribution factor. This is the table for finding the distribution factor. So joints, we have to find out the distribution factors only at the joint. So here we got two, B and C are the joints in this frame. So I have taken B and C. Joint B, we have the member BA and BC. For joint C, we have the member CB and CD. So I have written here, and to find out the K value, see for member BA, far end is fixed. If far end is fixed, we need to take the formula I divided by L. See here, if far end is fixed or continuous, then we have to use the formula I divided by L. So we have to use this formula. So for BA, we have the formula I divided by L. So one more thing is, in our frame, here the I value is given. We need to substitute this value. So for AB span, we have the I value 2I. So substitute 2I divided by our L is, length is 4 meter. 4. Simplify this, it will come out as 0.5I. For now, for member BC, the frame is continuing here. For continuous frame, so we have to use the formula I divided by L. So here also we need to use I divided by L. So here I is 1I, and our length is 3 meter. So I divided by 3. If you do, it will come out as 0.33I. Now summation of K, we need to add 0.5I plus 0.33I. So it will come out as 0.83I. So if you find the distribution factor, so DF is equal to K is 0.5I divided by summation of K is 0.83I. So it will come out as 0.60. So 0.6 now if we see for the member BC, DF for BC, DF is equal to, our K value is 0.33I divided by 0.83I. So it will come out as 0.39. So now we will see for the CB span. For span CB, it is a continuous frame. It is not ending here. So we need to use the again I divided by L formula. Means again we need to use the I divided by L, I divided by L. So I is, for CB I is 1 and span is 3. So it will come out as 0.33 I. For CD, this is a fixed end, we need to use the I divided by L, and our here I value is 2I and span is 4. I divided by L, I is 2I, span is 4. It will come out as 0.5 I. So now if you do the summation of K, 0.33 I plus 0.5 I, it will come out as 0.83 I, again same value. So now if you calculate the DF for member CB, so that is 0.33 I divided by 0.83 I, it will come out as 0.39. Same value here and here. For also DF you have already calculated, so it will come out as 0.60. So this is the DF. So next step is to calculate the moment distribution. Before going to moment distribution table, here one more thing I want to tell you. So how you get to know whether whatever I have calculated till now is right or not? If you add these two values, that is 0.60 and 0.39, the value should be 1. It should not be greater than 1 or less than 1. Or 0.99 is also okay, but in this case I am getting 0.99, it is also okay. The answer is right. Here also getting 0.99, it is okay. So now we'll move to the calculation of the moment distribution. So our step 3 is to find out the moment distribution. So this is the moment distribution table. This is how we have to draw this table. This first row has the joints. So in our frame we have the 4 joints. That is A, B, C, D, and for A we have the member AB, and for B we have the member BA and BC, and for C we have the member CB and CD. For D we have the only one member DC. So I will show now. I have written here, and this is the distribution factors value which we have calculated. I have written here, and fixed and moment values also I have written here. And our next step is to find out the balancing. Balancing means in last video I have already explained. One more time I will explain. Balancing means we need to add these two, then make it to opposite side. It means if you get the value in positive, then we have to make it into negative sign, and if you get the negative sign, then we have to make it to positive sign. Then multiply this value into the distribution factor. So I will show you. So now 0 plus minus 15, it will come out as the minus 15. Then make it into positive. So 15 into this 0.6. If you multiply, we'll get the, here there is no value, keep it as 0. We'll get 9. And if you multiply this positive 15 into 0.39, it will come out as positive 5.85. Same thing happens here. First add these two. So 15 plus 0, it will obviously come 15. Then make it into opposite sign, that is it becomes minus 15. Then minus 15 into 0.39. Multiply minus 15 into 0.39. It will come out as minus 5.85. Here also minus 15 into 0.60. It will come out as minus 9. So here no value, keep it as 0. Then carry over means we need to do half of this and send it to the opposite side. So our half of the 9 is 4.5 and 0 is same as it is. And here also 5.85. If you do half, it will come 2.92. If you do half of here, it will also come minus 2.92. Same here. The half of the 9 is minus 4.5, 0 as it is. So now we need to continue. We have to keep on doing until we get them at joint B and C 0, or if we get the nearer value also, it's okay. So I'm doing balancing same, minus 2.92, it will become positive 2.92, then multiply 2.92 into this 0.60, then it becomes, so then it becomes 1.75, positive 1.75. And here also 2.92 into 0.39, it will come 1.13. So here also 2.92, it becomes minus 2.92, then multiply minus 2.92 into 0.39, it will come out as minus 1.13. So again minus 2.92 into this 0.60, it will come minus 1.75. So here 0, keep it as it is. Carry over means we need to do half of this and send it to the opposite side. So 1.75, if you do half, it will come as 0.87, and 0 as it is. If we 1.13, the half of this is 0.56, and half of this is minus 0.56, and here also, so minus 1.75, if you do half, it will come 0.87. See here, the value is it's coming in negative, minus 0.50. It's near to, it is okay if you stop the here, it is okay, but this value is near to 1. I want the value nearer to the 0 value. So again I am going to do one more step. If you want to stop, no problem, you can stop it only here. Also you can further also calculate one more time. So I am calculating one more time. So minus 0.56, it becomes positive, that is 0.56, then multiply 0.56 into 0.60, it will come out as 0.33. Here also 0.56 into 0.39, it will come out as 0.21. Here also 0.56, it becomes negative, that is minus 0.56 into 0.39, it will come minus 0.21. And here minus 0.56 into 0.60, it will come minus 0.33. Here 0. So balance means same, do half of this and send it to the opposite side. 0.33, half, if you do half, it will come 0.16, 0 as it is. And here 0.21 half, it becomes 0.10. Here also minus 0.10. Here also minus 0.16. Here 0. So now we got the almost value nearer to the 0. So always we need to end our problem at the balancing only. So I am doing it. So minus 0.10, it becomes positive 0.10, then multiply 0.10 into distribution factor 0.60, it becomes 0.06. And here also 0.10 into 0.39, it will come 0.03. Here also 0.10, it becomes negative, that is minus 0.10 into 0.39, it will come minus 0.03. Here also minus 0.10 into 0.60, it will come minus 0.06. So here almost we got the value nearer to the 0. So now I am stopping here. So now next what we have to do is we need to find the final moment. It means we need to add these values, expect the distribution factors. Now I am adding, that is 0.45 and 0.87, 0.16. If we add this, we'll get the final answers. Yeah, maybe we get 5.53. So if you for BA, we get the final moment. For BA 11.14 we get, and for BC we get minus 11.14. For CB, we get 11.36, and for CD we get minus 11.14. For DC, for last DC we get minus 5.53. So these are the final moments we got. See here, whatever we have calculated till now is right or wrong. How to check it? If we add these two, the value, the final moments of the joint, if you add these two, the one value should be in positive and one value should be in negative. If you both add, it will almost get the 0. Here also it will get 0, nearer to the 0. It means whatever we have calculated till now is right. This is the how we need to check the whatever we have calculated till now is right or wrong. If you get the value at 0 or nearer to the 0, some value 0.1, 0.2 like that, or 0.01. If you get like that, the whatever you have calculated till now is right. So next, so these are the final moments. So MAB is positive, it means it is clockwise. So BA also clockwise. This is anti-clockwise. BC is, and this is clockwise, and CD is anti-clockwise, and our DC is also anti-clockwise, negative. So now we'll go for the calculation of the reactions, because so in our questions they asked to analyze the frame by moment distribution method. So analysis means we need to find out the reactions. Now we'll go for the calculation of the reactions. So our next step is to calculation of the reactions. For that, so what I'm doing is, this is the given frame. I am drawing this frame into like this. I am unlocking this. The same value I have written. So now it is easy for calculation of our reaction. It will be easy. So I am drawing this frame into like this. So now I'll find out the reactions for AB span. So for AB span, for finding out the reaction, here RA takes place, here reaction RB will takes place. So now apply the moment about A is equal to 0. Clockwise is positive. So here our moment about AB we got the 5.53. See here, AB we got 5.53, it is clockwise, and for BA also we got 11.14, it is also clockwise. So the value is 5.53, it is also clockwise, 11.14. So if it is clockwise, so it means positive 5.53 plus 11.14 minus RB. So it is anti-clockwise. So RB into distance from here to here is 4. 4 is equal to 0. So if we do, we'll get our RB value as 4.16 kilonewton. So positive value, it moves upward. So now if we do the summation of all the vertical forces is equal to 0, it means upward we need to take the positive. Here upward reactions are RA and RB. So we don't know RA value, so RA plus RB we got is 4.16 is equal to 0. So our RA value will come out as minus 4.16 kilonewton. So it is negative, no? It means moving downward. So this is the RA and RB value for span AB. So similarly, if you do for the span BC, so here RB takes place, reaction here RC takes place. So the moment at BC and CB will see. Here moment at BC is minus 11.14, it is anti-clockwise, and CB is 11.36, it is clockwise. So we'll write here. So minus 11.14, we don't need to write here negative sign. The symbol itself says it is negative. And positive 11.36, positive 11.36. So now we'll calculate the reactions. Summation of MB is equal to 0, clockwise positive, so it is moving anti-clockwise, so minus 11.14 plus UDL is there, it is moving clockwise. 20 into total distance is 3, it is always act at the distance of L by 2, it means 3 divided by 2, plus it is clockwise 11.36 minus RC. It is anti-clockwise, rotates, so minus RC into distance is 3 meter, so 3 is equal to 0. So if we calculate, our RC value will come out as 30.07 kilonewton, so it is positive. So similarly, if we calculate the RB value here, the reaction RB, summation of all the vertical process is equal to 0, it means upward positive. So RA and RC are the here upward reactions. So our RB plus RC we got was 30.07 minus UDL is there, it means 20 into 3. So 20 into 3 is equal to 0. So our RB value will come out as 29.93 kilonewton. It is also positive, it means it is moving upward. Similarly, if you find out for the span CD, the moment values for CD and DC will see. For CD, here for CD we have the minus 11.14, it is anti-clockwise rotating, and for DC we have minus 5.53, it is also anti-clockwise. So we'll see here. So it's anti-clockwise, minus 11.14 and minus 5.53. We don't need to put negative sign because the symbol itself says it is the value is negative. And here reaction RC takes place, here reaction RD takes place. So to find out the here reactions, we'll do summation of MC is equal to 0, clockwise positive, this is moving anti-clockwise, so minus 11.14, this is also anti-clockwise, so 5.53 minus this is also anti-clockwise, RD into span is 4 is equal to 0. If we do, our RD value will come out as minus 4.16 kilonewton. The value is negative, it means it moves downward. So next we'll find out the RC. For that, summation of Fy is equal to 0, upward positive. So here upward processes RC and RD, so we have to take, so RC plus RD value we got, that is minus 4.16. I am directly substituting that value. RD value is minus 4.16 is equal to 0. So our RC value will come out as 4.16 kilonewton. So it is positive, it means it is moving upward. So these are the reactions we need to find out. So now we need to find the final value. So now we got the RA value is minus 4.16. So see here, the RA value is only one, that is minus 4.16. So right here, so RA value is minus 4.16 kilonewton, that is negative moving, it means moving downward. And now find out the RB value, and see here the RB value is here 4.16 and here also 29.93. So add these two to get the final RB value. So RB value is equal to how much? 4.16 plus 29.93. If you calculate this, it will come out as 34.09 kilonewton. So it's positive, moving upward. So similarly, we calculate the RC. So see here our RC value is here 30.07 and here also 4.16. Add these two to get the final RC value. So RC is equal to 30.07 plus 4.16. If you do, it will come out as 34.23 kilonewton. This is also positive, it means moving upward. Finally, our RD value is, see here we have only one RD value here, that is minus 4.16. This is also negative. So our final RD value is minus 4.16 kilonewton. This is moving down because negative. So these are the final reactions. This is how we need to calculate the reactions. So see here one more thing. So one more thing is, here we have considered our RA value, it is moving upwards, but we got our final value in minus, that is minus 4.16, means it is moving downward. It means we need to correct it. We have considered it as positive, but it's moving downward. We need to correct it. So downward. And here RD also we have considered that it is upward, but it is moving downward, because our value we got is minus 4.16. that is we got the negative value. It means we need to correct it. So remember this is the very important. So this is how we need to calculate the reactions. And our last step is to drawing the bending moment diagram with the help of the moments, final moments, which we have calculated by calculating the moment distribution. So we'll draw. So this is the bending moment diagram I have already drawn. So this is the UDL for UDL. So for UDL we have the bending moment diagram like this. So I have drawn this. So I have drawn this to here. So now look here, for finding the maximum height of this UDL, we have the formula WL square divided by 8 we need to use. So WL square divided by 8, our W is 0.20 and our L is 3 divided by 8. 20 into 3 square divided by 8. If you do, we will get answer 22.5. So I have already calculated. So now see here, for span AB, our RA reaction is coming downward. It means if we put this to here like this, so if I bring this span AB to here, so our reaction will be like this, in this direction downward. So how, like this, it is like this, that is we got 4.16. and for similarly for CD also, if I put this to, see, if I bring this on this, our RD reaction will be like this, in this way, like this, 4.16. It will be like this. So if I bring our span, this span as it is, span BC, if I bring this to here, so what happens, our support reactions A and D, RB and RC will become our support reactions of A and D. See, if I bring this to here, our RB and RC becomes the support reaction of point A and as well as D. So for here, RB and here RC become the support reactions of A and D. At point A and D, our moment will take place. So MA at point A, see here, at point A our moment is 5.53, it is clockwise. So here it's clockwise, 5.53. So at point D there is a moment at point D here. See, the final moment is minus 5.53. It is in anti-clockwise. So anti-clockwise 5.53. So now we will see the net bending moment of this. So for our point A, see, our final point A, our final moment is 5.53. So it is positive. So 5.53 means it comes here, positive. And at point B, our final moment is 11.14. We need to see the always the first point is here B. No, we need to see here B. So at point B our value is 11.14. So 11.14 means it comes here. And when it comes to span BC, so for BC here first the first point is B. No, we need to see that minus 11.14. So at B minus 11.14 means it comes below this. And for CB our value is 11.36. So our for C, no, we need to for C point we need to 11.36 means it comes here. And for CD we need to see the first point. So CD our first point is C, no. So for C we have the value minus 11.14. Minus 11.14 means it comes here. And for DC our first point is D. We need to see that D where the value is minus 5.53. So minus means it comes here. So now join it. I will join. So this is our final bending moment diagram. This is negative, this portion is, and this is positive. If you want you can shade it like this. The line which what you are seeing in green, this is the net bending moment and this is the bending moment. We need to draw both. Here our problem ends. If you like the video, like it, share it and subscribe for the more videos. Thank you for watching.